Alright, welcome back and let's solve the Leetcode problem. So the Leetcode problem is delete the middle node of a linked list. I think this is a weak of a linked list since we solved the maximum of the pair linked list node yesterday. I think we can reuse some of the approach from there. So we are given a head of a linked list. We have to delete the middle node and return the head of the modified linked list. So yeah, the middle node of a linked list of site n is n divided by 2 lower bound. Note from the start using the 0 bits indices where x of lower bound denote that the largest integer is less than or equal to x. For instance, so n of 1, 2, 3, 4, 5, the middle nodes are, so if we divide the 1 with the 2, so if you take the lower bound, that's a 0. So for the 2, that's the 1. 3, that's also the 1. 4, that's 2. And 5, that's also 2. Okay, let's check the XML. I intentionally left the some of the notes from the yesterday so we could reference this together. So let's check the XML one. So let's consider that we have 6 nodes totally, and then if we want to find the middle, so 7 is definitely the middle, so we have to attach the next of the index 2 with the index 4. That would be 1, 3, 4, 1, 2, 6. Yep, that's as we expected. The same for the XML 2, but if we divide in half, that is not the approach, but we have to do the lower bound according to the this indicator in here. If you notice that this is not the array, it's showing like the lower bound. This is upper bound according to the mathematics term. But we can also check in here if the n is 4, we have to return the size of 1, 2, 3, 4 here. So second. So that means the 0 base index 0, 1, 2. This is our middle, and we have to return 1, 2, and 4. The same here. So 2 divided by 2 is 1. So index 1 is here. So we just cut off this and return the 2 in here. So the constraint is the number of nodes could be a range of 1 to 10 power 5. That is 100,000. Right, I think we can use the 2-point approach from yesterday by using the slow and fast pointer. Let's do the slow and fast pointer approach. Let's call fast will be the head, slow will be the head also. Now what we want to do is while fast is not equal to nil and fast dot next is not equal to nil, we're gonna iterate true. And then what I'm going to do is slow will be the slow dot next, fast will be the fast dot next. So we have received what we want in here, which is let's try to print the values. Slow dot value and fast dot value. So we have received like 7, which is the slow, which is a half in here, and 6, which is the end of the array. Not the array, it's a linked list, my bad. So in here, we got the middle, which is 3, and the end is 4. And the case 3, we got the 1, which is the slow. That means we can consider the slow is a half. How do we keep track of that slow, previous version of slow? That I can only think is how about we use a new variable called previous of slow. That is going to be the list node. And what I'm going to do in here is I'm going to keep track of previous of slow will be slow. And then I have to attach back the previous of slow with the fast of slow dot next. where I build the slow of next. So technically we have slow is half. So half of next is 1 and then previous of slow is 7. So we technically link the 4 and 1. And we just return the head in here. Cool. Well, how about we try to submit it? Oh snap, we need to consider of the what if only had only one node for the linked list. We can just have a base case like head of next is not equal to nil. Return, yeah, perfect. Let's check together. Alright, I think the time complexity will be the O of n and space complexity will be the O of 1. Because we don't use any other data structure aside from 3 variable, which is a shame for me. And for the time complexity, we just use the simple point approach, so which is O of n and then which is O of 1 here. Alright, that's pretty much from my side, and I hope you guys enjoyed the video and see you in the next one. Bye!